Okay, so in the previous class we've done this example 12.9. Let's now go to question number 1, okay? Page 227. So let us go there. Question number 1. The textbook page 227. Okay, let me read the question for us. Judge, the word judge there means simply calculate, okay? The judge or calculate the equivalent resistance. That means we have to understand it that way when the following are connected in parallel A. Okay, so let us write here. A has got 1 ohms and then 10 to the power 6 ohms and 10 to the power 6 ohms, these two in parallel. So it will be something like this. You can draw if you want. Here 1 ohms connected to 10 to the power 6 ohms. 2 ohm is the unit of resistance. Parallel means both of them are joined to the same point. Beginning point of 1 ohm is this A, let us say. Ending point is B. So also the beginning point of 10 to the power 6 ohm resistance is A and B. So both of them have same starting point and ending point, means if they are connected like that with the same starting point and ending point, one above another, we know that is called this one parallel. So this is how it goes. Okay, if you want to put switch, maybe switch on, then we know current will begin to flow in this manner and come out. But they're not asking for current, so let us not bother too much about that. Now let us see here. So just the equivalent means, the word equivalent simply means total only. So we have been frequently using total. Now that RP, let's say RP1 BD equivalent, we were previously using total. Now we're replacing it by a new word called equivalent, but the meaning is same. Be the equivalent resistance, okay, equivalent resistance of the according to the question, this is 1 ohm, so I can write here of the 1 ohm and 10 to the power 6 ohm resistors. And important for us to mention, they are clearly in parallel, because as we said, the beginning point of 1 ohm and 10 to the power 6 ohm both are A. Ending point of these two resistance, the 1 ohm 10 to the power 6 ohm, both are B. So here that is parallel, right? So therefore their equivalent will follow this parallel formula. So let us do reciprocal of the total or equivalent. Reciprocal of the equivalent, we have decided to put RP1 is equal to 1 by reciprocal of first one, means reciprocal meaning is 2 by 3, then numerator go up, denominator, this is called the reciprocal of 2 by 3. Similarly, reciprocal of 1 will be 1 by 1 ohms. Reciprocal of 10 to the power 6 will be 1 by 10 to the power 6 means 1, 2, 3, 4, 5, 6 zeros. Same thing only, right? This much ohms. So reciprocal is 1 divided by 10 to the power 6. Okay, so just a matter of solving it patiently and carefully. We know very simple, this LCM of 1 and this one, how much is that? 1, 2, 3, 4, 5, 10 leg. Okay, 10 leg will be the bigger one. 10 leg, 2, 3, 4, 5, 6 ohms. Then here 1 into this very number will be this, right? 1 into 10 leg. So 10 leg into 1 will be 10 leg. So 1, 2, 3, 4, 5, 6 plus 1, 7 digit is 10 leg, right? So plus 10 leg into 1 is this. So 1 into 1 will be 1, okay? And we can continue and write here. That will be equal to 10 leg 1, 2, 3, 4, 5, 1. 10 leg plus 1 is 10 leg 1, right? By 10 leg. So 10, 1, 2, 3, 4, 5, 6, and ohms is here. Here is 1 by RP1. Let us be mindful of that. Now cross multiply down and up means RP1 into 10 leg 1 is 10 leg 1, 2, 3, 4, 5, 6 into RP1. Then down and up, or up and down after equal. So 10 leg into 1, 10 leg 1, 2, 3, 4, 5, 6. Okay, then after cross multiplying, we have to find the equivalent resistance RP1. This one, so don't shift that. And 10 leg 1, 2, 3, 4, 5, 6. By this will come down, so 10 leg 1, 1, 2, 3, 4, 5, and 6. Along with the ohm should be in the 10 leg, sorry, 10 leg into 1, 10 leg ohm. So this is ohm is on the numerator now. Okay, so here, see here, 10 leg into 1, 10 leg ohm into 1 is 10 leg ohm. Okay, so if we divide this, then numerator will be the dividend 1, 2, 3, 4, 5, 6 divided by 1, 2, 3, 4, 5, 6. Same number of digits, but this is bigger, so it won't go unless you put 0.10 will come here. So obviously we'll go with 9. So 9 ones are 9. 1, 2, 3, 4, 5 zeros. So 9 zeros are 0, 0, 0, 3, 4, 5. 9 ones are 9. Then we go 10 minus 9, 1, and 9, 1 taken from here. So from here borrowed. So 10 given 1. So 9 left. 9 left given 1. Given 1, 9 left. Given 1, 9 left. Given 1, 9 left. 10 here now. From here 1, 10. Then given 1 here, 9. So this is 10 minus 9, 1. So 9 is left. 9 is left. 9 is left. 9. And here also 9 is left. And here nothing is left. 9 minus 9 is 0. This much. So 1, 2, 3, 4, 5, 6. But here 1, 2, 3, 4, 5, 6, 7 digits. So because of this point, you can put 1, 0. Again, 9 will go. So this will become 9, 1, 2, 3, 4, 5. 1, 2, 3, 2, 3, 4, 5. 1, 2, 3. Wait. Here. 1, 1, 2, 3, 4, 5. And then here 9. 9, 9. So you can just stop in second place. And approximately it will be 0. Equivalent resistance is 0.99. First answer. Okay. Then let us go to the B. So B is, you have 3 now, 1 ohm, 10 to the power 3 ohm. So 10 to the power 3 ohm, and then 1 more. So, and 10 to the power 6. So 3 ohm, 3 are connected, 10 to the power 6 ohm. So 1 ohm, 10 to the power 3. Okay. And 1 more here. You can connect here like this, I think now. Here, extra 1, 3 are there. 10 to the power 3 ohm, 10 to the power 1, first one. And then this one is 10 to the power 6. 3 of them in parallel again. So we have to calculate. So draw this diagram if you want, it helps. So we can draw RP2, second case. Equivalent resistance of the 1 ohm, comma. 10 to the power 3 is the second one, sorry. Ohms, and 10 to the power 6 ohm resistors in parallel. Okay, and then we can start solving from here to find the value of the second equivalent resistance. Same idea only, so that's why we can just go like that without explaining much this time. Now let's do now. Since they are in parallel, beginning point of all these 3 resistances A, ending point is B. So if 2 or more resistors have the same beginning, starting and the ending point, one above another, that is called parallel. So we have to use parallel formula. 1 by equivalent RP2 will be equal to 1 by first one, 1 ohm, second one, 1 by 10 to the power 3 means 30 ohm. 1 by 10 to the power 6 here means, we know by now there will be 6 zeros. 1, 2, 3, 4, 5, 6. 1 followed by 6 zeros, or 10 to the power 6 is same, right? And not forget to put ohms. Then here we are going to get here, calculate carefully is what we have to do. So here LCM of this will be the biggest one, is going with also 1, 2, 3, 4, 5, 6. 1 into this, so this into this is 10 leg again. 1, 2, 3, 4, 5, 6 zeros plus 1, 7 digits, plus 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, so up to here, zeros. 3 more zeros, so 1000 into 1. What I mean is 30 already accounted here, so 3 more left. We'll multiply this, means 1000 into 1. 30 means 1000 into 1, 1000. And this is the same as the LCM with this, so this into 1 will be this, and 1 into 1 will be 1. So we know that, right? So next year, when we add all these, we're going to get 1, 2, 3, 4, 5, 6, 1, 2, 3, and then 1, then 1, 0, 0, here 1, 0, 0, 1, 1, 2, 3, 4, 5, 6, 7 digits. So 1, 2, 3, 4, 5, 6, 7 digits. Be careful to make sure you count carefully. Divided by 1 followed by 6 zeros, 2, 3, 4, 5, 6, and ohms is here. And here it will be 1 by RP2. So cross multiply, you're going to get 1, 2, and 1, 0, 0, 1 into this RP2, which we have to find. After equal sign, this into this is 1, 2, 3, 4, 5, 6. Not forgetting to shift the ohm with it. Then it's just a matter of RP2 equivalent resistance is what they're asking us to find. 1, 2, 3, 4, 5, 6 ohms divided by this will come down to the denominator. So 1, 2, 0, 1, 0, 0, 1, like that, right? So if you divide this, then we're going to get approximately almost the same. I think let us divide 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 divided by this one, 1, 2. So 1, 2, 3, 4, 5, 6, 7. Here also 7 digits. This is bigger, so 0 point we have to put, then 0. 9 will go, I think 9 ones are 9, 0, 0. Then 9 ones are 9. 0, 0 again. 9 ones are 9. So here 10 minus 9, 1. 1 shifted, then 1 become 10. 10 give 1 here, then become 9 itself. And 10. 10 give 1 here, then 9 it becomes. This has become 10 because of the 1 borrowed from here. Then 10 give 1 here, then 9, 9, 9. 9. Finally here 10 minus 9, 1. 9 is left, therefore 9 is left. 9 minus 9, 0. 9, 0. 9 minus 0, sorry, 9. 9 minus 0, 9. Then 9 minus 9, 0. Already borrowed, so nothing left, so this much. Then again point means 1, 0. Again 9 will go, I think, so 9, same thing, 0, 0, 9, 0, 0, 9. So we can stop there. So approximately 0.99 ohms is the equivalent resistance, even in this case B. So second answer. Okay, we have one more question here. See here, 2. So let us do that also. I think we can do that. Yes, 2. So let us check the question and see how it is going to go there. Let me read the question. Electric lamp 100 ohms, toaster 50 ohms, and water heater, water filter 500 ohms resistance connected in parallel. So let's write here. You have to, what is the resistance of the electric iron? Okay, in parallel, what is the resistance of another electric iron complete connected to the same source, means 220 volt, that takes as much current, means same current as those 3 that we've mentioned just now. And what is the current through that single one? Okay, so here question number 2, page 227. Okay, let's do slowly. Let RP be the total resistance of the 100 ohm lamp. I'm writing in short again, lamp, comma, 50 ohm toaster, and one more is there, 500 ohm filter, water filter. I'm writing in short. Clearly question says they are in parallel. This is important. So because these 3 resistances here are in parallel, 100, 50 and 500, we have to use the parallel formula, this one. So 1 by RP will be 1 divided by the first one is 100 ohms, second is 1 by 50 ohms, the third one is 1 by 500 ohms. Okay, so that's how we go about. Then here we see textbook page 227. Okay, so Let's do this. That implies here 1 by RP, the total reciprocal of total is 105, 550 into 10. So these two smaller number, which are smaller to the biggest 500, are both multiples of 500 is multiple of both these two. So the biggest one will become LCM, in that case 500. 100 into 5 is 500, 5 ones are 5. 50 into 10 is 500, 10 ones are 500 into 1 is 500, 1 ones are 1. So we're going to get here 1 by RP is equal to 16 divided by 500 ohms. So I think 4 will go here. 4 fours are 16. How do I know? Because the number ending with 20 always go by 4. Okay, 4 ones are 4 1 in hand. 4 2s are 8, 9, 10. 4 5s are 20. So let's keep it like that and cross multiply, and then you're going to get RP into 4 is 4 into RP. Then down and up, 125 ohm into 1 is 125 ohm. So you're going to get RP is equal to 125 divided by 4 ohms. So we're going to keep this one as equation number 1. Total resistance of these three together is this much. Then what is the resistance and the current? So we have to find the current. So let I equal to question mark is the current through them. The word them here implies plural, these three. So we know that to calculate that we need to use Ohm's law, V equal to I into R. Now we know V is given already as voltage supply in the question. The potential difference, total potential difference or potential difference, same thing, only look into your text, you will see their source is 220, right? Yes. Then we need V and we need R to find I. So R is already here. RP is equal to here 125 divided by 4 ohms. Because we are getting this one by using equation number 1. So if you have V and R, you can easily find I. So using Ohm's law. So you write here using Ohm's law. Okay. Let's write the general equation first. Maybe you like to go there, but in this case, our total is RP. So we want to find I, so don't shift that. V divided by this RP, you shift, then it will go to, from numerator, it will go down to denominator. This is 220 volt, as you can see here, V. RP here you can see is longer line here, this equal then 125 divided by 4, as you can see here, ohms. Don't forget to put that, then that is I. Now you see here what 220 long line means divided by. If you change the multiplication sign like this, then this down, denominator 4 will go up, numerator 125 will come down. Volt by ohms, we know SI unit of current here. Simply you can put it as A on the numerator, this much ampere. So 5 4s are 20, 2 in hand, 5 4s are 20, 5 2s are 10. Okay, so this is 44 into 4 by 25. So 4 4s are 16, 4 4s are 16, 1 and 4 is 16, 176 by 25 ampere is the current that is flowing through this. And you can put this one as equation 2 if you want. So total resistance they asked, we found, current we found. But we have to, this is the answer, but we have to write in the format the question is asking. So let's go there and see. The question is saying these three put together, the total resistance this much, total current flowing through them this much. Then the last sentence, what is the resistance of an electric current? So electric iron connected to the same source. So since question is saying, since this, now it is the single, another single electric iron, instead of those three they put single electric iron, but the condition is electric iron connected to the same source, means potential difference, same source. So V equal to 220 volts, same source. Okay, look the equation, this is written, that takes as much current, this is the keyword, that takes as much means same current, as much current means same current as the 3 together. This single one also taking, single one is taking the same amount of current with those 3 put together. Okay, that is the clue. And what is the resistance? Takes as much current as all the 3 resistance, as much current as all the 3 appliances. Previously they put the 3 appliances, water filter, hot toaster, and then lamp together. They were consuming this much current, 3 of them. They remove all those 3 and put this electric iron, and this single iron is consuming same amount as the 3 put together. That means total current, question is asking what is the total current through this single one. Since it is consuming as much current, so it will be the same current. Therefore, what is the current? So therefore, current through this electric iron is, therefore electric iron is same current, so I equal to this one, 176 by 25 ampere. Actually this is the current consumed by the 3, but the question is saying this single one also consuming same current, means this is the same answer, same current. So just a matter of, and you can write your since using equation number 2. I will divide this. So let us divide 176 divided by 25. 7 5 are 35, 7 2 are 14. Yes, so 1 in hand, 0.0. Still 10 is less than 25, means 0 and 0. 25 4s are 100. So that is our answer. That is here 7.04 ampere. So 0.04 ampere is consumed by this single electric iron. Same amount is consumed by those 3 put together. First answer. They're also asking what is the resistance? Look there. What is the resistance? So next question, just write down. Question is asking, we want to write like this. What is the resistance of the electric iron, single one? So think about this. Same source, so we write here V equal to, same source, so V equal to 220. Then same current, so you can write here, therefore resistance of the iron will be same as that of the 3 appliances put together. How do you know? Because it's very simple. You see V equal to I into R. They have same resistance already established. Same current is flowing already established. Then same voltage, same I, same V as the 3. Then R will be surely same, right? So that is, the resistance is RP only, which is equation number 1. 125 divided by 4 ohms. Since using equation number 1, if they have the same I and the same V, same source as the question is saying, then it will have the same R, because the question is V into I equal to I into R. Therefore this is 4 3s are 12, no in hand, 4 1s are 4, 1 in hand, 0.0, 4 2s are 8, 9, 10, 4 3, 31.25 ohms will be the resistance of this single iron, and this will be the total of the 3 because they have the same resistance. First answer, second answer. So now you can go and give the test. Okay.